Okay, so I'm going to do chapter 13, number 16, and we're supposed to consider the following stock return data. So we have stock 1, 2, and 3, and then we have the 8 or 12 different years. And we're supposed to construct the Markowitz portfolio model using a required expected return of 15% and assume the 12 scenarios are equally likely to occur. Then we're going to solve the model using Excel Solver, and then we're going to solve the model for various values of required expected return and then plot the efficient frontier. So what we're going to do is we're going to let X, Y, and Z be the fraction of the portfolio in stock 1, 2, and 3. So that's going to be X, Y, Z. And so what we want to do is minimize, now since we have 12 different options, 1/12 the sum of S going from 1 to 12, R of S minus R bar, quantity squared. And really what we're doing is our objective is to minimize the variance for this portfolio such that, and then we're just going to put all these things here in. So 0.30x is going to be the first thing plus 0.225y plus 0.149z. And we just keep doing that for each one of these. And so then we have these 12 basically equations, and our RS is going from 1 to 12. And then we have the x plus y plus, that's supposed to be z. I can't type, obviously. That's going to be equal to 1, adding them all together. And so then what we have then is the 1/12, the sum of RS's from S equals 1 to 12 is going to be R bar. And then R bar is going to be greater than or equal to 0.15 because it says the expected return has to be greater than, or it's 0.1 or 15% or 0.15. And then X, Y, and Z has to be greater than or equal to 0 in this case. All right, so what do? Well, first of all, we need to go type basically all of this back in, or this table here, into our model, so our parameters. And so again, these are going to be our 12 scenarios, or 12 years is how I'm doing it. And we have stocks 1, 2, and 3, our X, Y, and Z, and then I just type that whole thing in there. Again, just straight out of the table. Hopefully I didn't make any typos there. Here, then I'm going to have a required return, and that's because we can have anything of 15% or whatever, but we can also plug in different values. So 15% is the one that they want to require, but we can go higher than that. And so I just I was playing around with it to see if it worked. So 0.4 was my last one. And so we're going to change the amount of X, Y, and Z. So that's what that is. The variance, that's going to come from down here, but we need to calculate the variance. We also have R bar, which is kind of going to be required return value, and then all that calculated. R, that's going to come into play. That's going to be what we're looking for in our solver. Scenario return, basically what we're going to do is we have the sum product of the B14 through B16 times the B5 to B7. So, in this case here. And then when we get over here, then it's going to be the C5 to C7. But we're still doing 14, 15, and 16. And then same here, except we're moving to D, all the way up through the 12 different scenarios for all the different values here. So the scenario returns is basically each one of these times our model part here, stock 1, 2, and 3. Now, deviation from the mean is just going to be the value above here, this R, that we come up with in our calculator over here in our solver, minus the right here, the R bar. And so that's going to be deviation from the mean, and that's the same thing through all of these. So we're just taking that minus that, and that's going to be the R deviation from the mean. And then we're going to do the deviation from the mean squared. So basically we're just going to square that value, square that value, square that value. Portfolio expected return is basically just going to be the average of the scenario returns. And our proportion sum is we're just going to take the sum of those values there. And then when we get done, we're actually going to have a graph we're going to make, which is going to be our efficient frontier graph. And how we're going to do that is we're just going to plug in different values here. So let's say we're going to do 0.15 because we said it had to be greater than or equal to 0.15. And we go to solver. I have to enter first. Then I have to go to solver. And again, what we're going to do is we want to minimize the variance. That's our whole key. We want to minimize our variance. And we're going to change all these different values. Let's see, I have to, let me Now hopefully it'll, all right, so now this is going to be our variance. These are different parameters we're going to be looking for to change, and it's going to be set per all these different items here. So B14 through B16, remember that's our stock 1, 2, and 3, they're X, Y, and Z. They have to be all greater than or equal to 0. Then the R values, the B23 to M23, that's going to be equal to the B24 to M24, which are basically, which you can't see here because I can only do one screen at a time. So we'll just tell you that. And so then we have the E20 has to be the B29, and the E20 has to be greater than or equal to F20, and then E29 has to be equal to 1. So we're going to say solve, and once we get this pulled back up over here, we're going to keep that solution. And so what we've done now is for the required return of 0.15, we find that X is going to be 0.530, Y is going to be 0.356, and Z is going to be 0.113. And our variance is going to be 0.025456. All right, and so what it's done is it's found our R's and varied those appropriately, and then gets all this done based on our, again, our equations. And so our expected return is going to be 0.15. The proportion sum is going to be 1. And so we're going to keep doing that for all these values. And so I did it, from 0.15, 0.2, 0.25, 0.3, 0.35, 0.4, and I got all the variances. So for instance, if we wanted to go 0.35, we'd hit enter, we do our solver, and then say solve. And so now X is 0, Y is 0, and Z is 1. And now instead of the same return, we only get 0.235. So our required return is 0.35, but our expected is only going to be roughly 0.235. So it's not as high here, and our variance is much higher than before. Before it was 0.0205, and now it's 0.0997. If we go up to 0.4, it goes to 0.1137. And as you can see, this is our efficient frontier, and we could take this even down further if we had wanted to, but they said it had to be greater than or equal to that 0.15. So I just started it there and went to the right. And so they would have to, the person looking at this would have to decide what the best mean and variances are, required returns and the variances, to see what one they would use to invest in. So that's how you would go about setting up something like number 16 using the Markowitz portfolio model. So hopefully that will help you.